Yeah, camps on everyone. Let's start off. So last class, we have done the last part was infinite GP. Others do keep your cams on. Perfect. Yeah, so before going ahead, let's see a few more problems and then we will go ahead. Who else is remaining? People are missing. Okay, let's start off with a question. Let's say we have, let's start with a simple one. Let's say we have a cylinder. The radius is R. Inside the cylinder, there is an ice cube. Right? It's an ice cube of side, let's say A. So I'll keep everything in variables. I can put numbers, but okay. And now, so basically it is a little bit on volumes and everything today. And we'll see something called Cartesian polar coordinates. So density of ice. So rho is the density. Rho ice is 0.9 gram per cc or 900 kg per meter cube. Similarly, density of water is 1 gram per cc or 1000 kg per meter cube. So assume the ice cube melts from all directions uniformly. So it will melt in every direction uniformly. So it will always maintain a cube shape. Others, you need to keep your cams on or else you'll be removed from the classroom in a minute. If the cams are not on, you will be removed from the classroom. So please do keep your cams on. Assume ice cube melts uniformly from all directions. So meaning you can assume it always maintains a cube shape. So when the ice melts, it will start forming water. Find the height of the water level when the side of the cube becomes a by 2. Meaning how will the picture look like? The ice cube will have become smaller, a by 2. And this water level, right? I'm showing in red. So the water will be something like this. It will be the side. This is the water level. I am asking you that height. Is it making sense? So when the ice melts, it becomes water. All the water will be there. So what is the height of the water level? answer comes in terms of R and A, I can give you values like R is 10 meters and A is 2 meters, but let's do it in variables. Let's see. Easy one, it is just based on volumes. You got an answer, you can type in the chat box with the co-host here. But yeah, answer is slightly complex, so might be a little difficult to type, that's okay. But give it a try, you got 2 minutes. How do we approach this? Everyone got the diagram, right? You have a cylindrical container. In that you kept an ice cube of side A. The ice cube started melting uniformly in all directions. The ice cube became A by 2. So if the ice melts, there will be water. So what is the height of the water level in the cylindrical container? Anyone not clear with the question? There are two important points there. No, Anuj, that's not the answer. There are two small traps there. Let's see whether you'll figure out two traps. I'll tell you the first trap. Say, if you take an ice cube, if you take a full ice cube, and if this thing completely melts into water, tell me one thing, what remains constant?
Volume.
If an ice cube melts into the matter, will the volume remain constant? Or mass
Yes,
remains
sir.
constant? Mass remains constant. You're getting it? If a material density changes, volume can change. What remains constant is mass.
Sir,
So mass of ice will be equal to mass of water.
Sir, but पानी तो उतना ही होगा ना.
So let's see now. Is your feeling or you know how to do that exactly? This is what I'm saying. You know what you're saying right now is your feeling. You don't have a proof for that. It is just your feeling. It will be equal, na? So that's what I'm asking. Will you have guts to mark the answer in the final exam like that feelings? Prove it. There, see, do you agree mass will remain constant? Mass cannot change, right? Law of conservation of mass. There is nothing called law of conservation of volume. So now what is the mass of ice? Density of ice into volume of ice is equal to density of water into volume of water. So in ice, there is something called an anomalous expansion. Ice is different. You want to try this? You can check it out. In your house, if you have a bottle, if you have a glass bottle, even better, take a glass bottle, fill up with water completely, seal this and put it in the freezer and see what happens next day morning. The glass will break. Ice expands. When you take water and freeze it, it expands. Volume increases, it will break the glass. So what is the density of ice? 0.9 gram per cc into volume of ice, right? And this is 1 into volume of water. There, so you can see volume of water will be 0.9 times volume of ice. It actually shrinks. So if the cube ka volume is a cube, this water will be only 0.9 a cube. Are you getting that point, everyone? If an ice cube completely melts, you won't get the same amount of water. You will get less water. You will get only 0.9 times of the water, 0.9 times of the ice ka volume. Is this clear, everyone?
Yes, sir.
Clear, Nanuj?
Yes.
Yeah.
Yes,
so
sir.
mass remains constant, not the volume.
Okay, sir. Something similar I was doing during board exam, so it just clicked to me. I thought,
Yeah, that is okay. But always be careful to prove it because exam won't there to correct you.
yes, sir.
Go to the next one. Shreyansh, you got something like that. You just write the equation and leave it. No need to simplify. It'll little bad. This is the first trap. I hope everyone got this. Then what? Now remember, the entire ice cube didn't melt. Only half of the ice cube, matlab only the side A by 2 is still remaining. Now what? So how much ice melted exactly, everyone? So initially we have a cube of side A. This guy became cube of A by 2. So the volume of ice melted.
7 a cube by 8.
Yeah, so it is not complete actually. So mass of the ice melted will be density of ice into the volume will be initial volume is A cube minus A cube by 8. This must be equal to the mass of the water. So this will be 0.9 into 7 A cube by 8. Mass of water is 1 gram per cc into volume of water. There. So actually you're getting this much water, which is 6.3 A cube by 8. This is the first thing. Samyak, that might be right, but let's see, numbers are bad. Is this part clear, everyone? So we have this much water now. Now you're taking this water and putting in that container. Any doubts on this part? Everyone, Advai, Pratyasha, clear with us? Vanshika, Ashvi, Tanishka, Shaunak, Ishman, Devanshi, clear with this? Now what are you doing? Now look at this. When you take this container and put it here, this is the second trap here. Not a big one, but yeah, some people do this mistake. So remember, there's still a cube blocking this thing here, A by 2. So if you look at this in the top view, if you see this from the top, how does it look? This is what you will see. You will see a circle and beach mein you have a cube which is blocking this much area, isn't it? So now you tell me, when the water which comes, do you think it will occupy the whole floor? The water will occupy the floor minus this green piece, isn't it? The water will only accumulate in this region. So the water will be somewhere till here. Let the height of the water be h. So this volume will be the area into height. What is the area? Pi r square minus this cube ka area, which is a square by 4 into h. Is that making sense? This is radius r. And this guy is a by 2. So the water will not be everywhere. The water will not occupy this green space. So this balance area will be pi r square, area of a circle, minus a square by 4. So water will occupy this remaining space. So this is the volume of water. So whatever water you got here, this must be equal to that. So this must be equal to pi r square minus a square by 4 into h is equal to 6.3 a cube by 8. You got everything there, so just shift there. So 6.3 into a cube by 8 into pi r square minus a square by 4. You can leave the answer like that. Is that clear, everyone? So the two traps in the question is, first trap is this. The mass of the volume of ice is not equal to volume of water. You'll always get 90% of it. So you'll always get 10% less. Whenever ice melts, you get 10% less water. Right? Second thing is this. Because the cube is sitting there, you don't occupy the entire floor. You occupy this entire disk minus this cube ka area. Is this making sense, everyone? There, I didn't teach you any physics here. It is just volumes and densities. But you get questions based on this. So the actual question in physics is this. At what size of the cube the ice will start floating? Now, if the water is coming, at some point this ice cube will float, isn't it? That is the actual question in the JEE. After what time, or at what height the ice cube will start floating in the water? It leaves contact from the floor. But yeah, it's a part of it. Any doubts on this? This part was clear, right? You want to try this as an experiment, should definitely do this. Recently, I did something like this. I took a steel, steel bottle, right? I filled it with water completely. I forgot to leave the space and I kept it in the freezer. Next day morning, I opened it. This thing literally got deformed. Matlab, it became like this. It really puts a lot of pressure. You want to check it out, check it out. If you put a glass, it will definitely break. You can even try with Coke tin. That is an easier one if you don't want to destroy the bottle and get scolded by mom. So yeah. Clear? Let's see one more. Any doubts? Clear, na, Ananya? Advait? Arya? Clear with this? Srihari? Perfect. Next one. We have a carpet. Just ignore my diagram. So we got a big carpet like this of radius r. We have a cylindrical carpet. Meaning kind of it looks something like this. Not exactly, but yeah, something like this. We have a carpet like this. Then what you did, you started rolling this carpet on the floor. So this carpet, it rolls down completely. So this is the time at t is equal to 0. So as this carpet starts rolling down, t is equal to 1 minute, the carpet looks like this. In t is equal to 2 minutes, the whole carpet spreads out. You're getting it? So someone started rolling the carpet with a uniform speed. So at this point, the radius is x. So here, the carpet rolls on the floor with a uniform speed. In 2 minutes, the entire carpet becomes flat. So the question is, what is the radius of the carpet at 1 minute? Find x, which is the radius of the carpet at 1 minute. Again, listen to this thing. We have a carpet, a solid carpet, getting it? I didn't draw it properly, but you got it right. The radius is r initially, that is given. Now this carpet starts rolling on the floor and you can see the carpet is on the floor and there is still some roll left over. In 2 minutes, the whole carpet becomes flat. Then what is the radius of this carpet or roll at 1 minute? How much is remaining here? Are you able to visualize with this diagram, right? How it is looking? Someone is rolling the carpet like this. Is the question clear, everyone? How do we do this? Hmm. Right, Samyak. We have one answer. Others, try.
So is it a numerical answer?
Answer comes in terms of R. So, main options, if I had to give you, exam options will be like R by 2, R by 3, R by root 2, R by root 3, something like this. Options will be like this. R by 4, R by 5, something like this. So, answer will come in terms of R. How do we approach this? Nee, Devanshi, that's not the answer. Right, Shaunak? How do we approach this? Tell me one thing. When you're rolling the carpet, what remains constant? The length of the carpet,
Yes, sir.
right? So I can also say the volume of the carpet is also constant then. Do you agree? So if I make this carpet, if you think about it, it's actually kind of a cylinder. So we have radius R, and let's say this length is L. So you can treat this carpet like a cylinder. Agreed? So what is the volume of the carpet? So let's assume there is no spaces, it's tightly packed. So volume of the carpet is cross-sectional area pi r square into L. Hope everyone knows volume of a cylinder. Clear? Now, when you open this full carpet, the carpet will look like this. Agreed? Where this would be the length of the carpet, that is this length. This will be the thickness of the carpet, which I don't know, right? And let's call this thing as distance d. What is the volume of this thing then? The volume of this must be equal to L d t. Isn't it a cuboid?
Yes, sir.
Make sense? But this and this are equal, isn't it? Because it is the same carpet. Because the carpet is same, the volume is still the same. So this must be equal to pi r square L. So from here we will get T into D is equal to pi into r square. This is one information we will need. Is this clear, everyone? And remember, this is the scenario in 2 minutes. So 2 minutes mein the carpet will be completely opened. Any doubts on this page? Right, Pratyasha, you got it. Now remember, I didn't give you thickness, I didn't give you length. All these are variables I assumed, so your final answer should not have these variables. Then what you did, now where t is equal to 1 minute, this is how your carpet started looking. Now tell me one thing. In 2 minutes, if this thing opens to a distance d, in 1 minute, how much will it open?
D by 2.
D by 2, right? Because the speed is constant. Does everyone agree with that statement there? In 2 minutes, the carpet will open distance d. In 1 minute, the carpet will open d by 2. This will be length L. This will be thickness t. And this radius is x. So now this volume of this carpet will be, now there are two parts here. The carpet on the floor, which is length L, thickness into d by 2. This is the carpet on floor. Plus we also have the small cylinder left over, which is pi x square into L. This is a carpet which is yet to be unrolled. This is the volume at 1 minute. Everyone clear with this? But tell me one thing, shouldn't this volume be equal to this volume again? Because see, no matter what you do, the volume of the carpet cannot change. Is that making sense? So therefore, this volume mul V, which is L T d by 2 plus pi x square L, must be equal to pi r square L. L will cancel everywhere. We'll get Td by 2 plus pi x square is pi r square. But we already know what is Td. Td is pi r square. So pi r square by 2 plus pi x square is pi r square. Pi also will cancel. You'll get x square is equal to r square by 2. We get x is equal to r by root 2. Is that making sense, everyone? See again what I did everything. First thing I did, I found the volume at t is equal to 0. I found the volume at t is equal to 2 minutes, which is completely a cuboid. So basically a cylinder became a cuboid. At t is equal to 1 minute, you have a small cylinder and you have some cuboid. You're getting it partially both of them. So basically I found volume at 0, I found volume at 1, I found volume at 2, and I equated all of them. Because volume is always constant. No matter how you roll the carpet, the volume will remain constant. Is this clear, everyone?
Sir,
Arya.
but then when you gave the problem, it was said that in a t equals to 0, the radius was x, right? So then how?
Where did I?
Oh,
Radius was r. So not sure what you're asking. Arya, Bruno.
Sir, you said that the speed was constant. If the
Right.
speed was constant, then the carpet wouldn't open in like half, and that assumption wouldn't be right.
Which one half?
So like you said, at t is equals to 1 minute, the
Yeah.
carpet will be half opened and half.
Yeah.
But if the speed was constant, then like due to the inner folds, would it actually be
That
half?
you don't worry, na. Someone is catching like this and opening, right? It will not go on its own. That you don't worry. It is somehow going constant. That is not our problem to deal with. Okay?
Okay. So the
So
rate
it is
of
given
opening the
constant.
carpet is same.
Yeah, meaning someone is controlling that. It is not happening on its own. Is this clear, everyone? But if I ask you this in the exam, how will I ask you? Now, this is the difference in school and here. School mein they'll ask you the same question and you'll get this answer and you're happy. But you know what I'll ask in the exam? Find the time when the radius is r by 2. Question is still the same. The question will be different. Find the time when the radius is r by 2. Did you see the question has become completely different? So who wants to try? You can do that thing as a homework. So at 1 minute, radius is r by root 2. So find time. Let's make it r by 3, na? Interestingly. There, I can ask you like that. You're getting this? This is what will happen. I will teach you one model, but I can still ask you 10 more models. And it won't be possible to teach you each and every model. So all that I can give you is an idea how to think and how to figure out. Is this clear, everyone? All got this? There, that is a bit about volumes. If you see, all that we did is just volume conservation. I didn't teach you anything new there. Next one. Clear now, everyone? Olivia, clear with this? Anuj, Advait, Aditi. Perfect. Next thing. Coordinate system. Now, this is one important thing. So what is this coordinate system? Basically, it is a notation to locate the position of a point. In simple words, I can say it's an address. Right? It's like an address. Think about it. If someone asks you, where is your house? What do you say? So and so, area, so and so street, so and so building, like 30th floor, 20th floor. So you actually, what you're giving is indirectly coordinates. So in coordinate system, right, there are a lot of different types of coordinate systems, right? But in physics 11th and 12th, we primarily deal with two types of coordinate systems. Once you go to higher level engineering and all, right, you have parabolic systems, you have pretty weird systems also. So we'll not deal with all that stuff. So first thing is your Cartesian coordinate system, which you learned in school. So this understanding is important because this will be the basics for, the vectors, the next chapter. So Cartesian coordinate system, let's see what it means. Let's start with a simple thing. Example, when you say the point is 2, 3. What do you mean by this? The meaning of this is when you're saying 2, 3, this is what you're telling yourself. Start from origin. Move 2 units along x-axis. From there, move 3 units along y-axis. That is the meaning of 2, 3. You could have done the other way also. First you can move y and then you can move x. So this is what you're suggesting. So travel 2 units here. And then travel 3 units here. There you reach the location. Making sense? Simple. That's what it means. Now in Cartesian coordinate system, whenever you want to go from one point to another point, you can't go however you want. So let's say you want to go from this point A to this point B, right? So you can't go like this. You can't just break through the middle and go this thing. So this is like some kind of road network. So you can go like this, you can go straight, then you can go like this. This is acceptable. You can go like this, 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 you can go like this is also fine. So either you walk along x-axis or you walk along y-axis, you can't do anything else. Or I could even go like this, right? Go like this, go like this, and go. All these are acceptable paths. This is how you travel. So to give an example, this is how Bangalore looks like. That's why the city is full of traffic anytime. The entire road network, if you see it, is like a grid. So traffic will get stuck at every jam. People are going anywhere they want. It is a mess. If anyone has been to Bangalore, you will realize that. I think some areas might be good. So this is how Bangalore network looks like. So in this case, you either travel parallel to X or Y. You can't go through the middle of the road. Clear? This is the standard stuff, 2D, but got the meaning of it? Now, if you take it in a 3-dimensional, then how does it look? In 3-dimensional, this is X, this is Y, and this is Z. Are you guys able to, how is this 3-dimensional plane? So when you say X, Y, Z, meaning from origin, travel along X-axis by X, then travel along Y-axis, so parallel to Y, like this, and then travel parallel to Z-axis, Z. You look at the point here, X, Y, Z. So basically this is 90 degrees and this is 90 degrees. Are you guys able to visualize how is the path? There, if you're looking into my screen, this is how it would look. So if this is the flat surface, right? you're traveling like this. If this is the screen, right? You're traveling like this, and you're coming out of the plane. So on a flat surface, it looks like this. You're going straight, right, and then you're coming up. Is that making sense how it is? So here, X and Y is the horizontal surface. So this XY is your horizontal surface, the floor. Z is the vertical height. So it's like this, a plane, and the Z is pointing out. So this is a 3-dimensional coordinate system. So generally, we prefer this system whenever you're studying motion in lines. This is the easy stuff, you know this in school, but I'm more interested in the next one. But I need to give you basics for this. So if somehow you can divide the motion into straight lines, this system is the best. But the problem in real life, do things really go in straight lines every time? Just look at your fan. Does it go in a line? Does the wheel of your cycle, when you're riding a cycle or when you're going on a motorbike, does it go in a straight line? Can you tell me, look at this thing. When you go into the lift, you have that fan, right? Lift mein. So if I choose one point on the lift ka fan, and the fan is rotating, and the lift is going up, can you tell me how will the path of that point be? You can listen to that. A point on the blade of a fan, which is inside the lift. The fan is rotating and the lift is going up.
Like
How
a
do you think the path
spring.
of point A will look like?
A cylindrical
That-
point. Like, yeah.
A will go in a circle and the
Spring.
path is going up, na?
Yes, sir.
This is how the path will look like. This is not a straight line. This is making sense. So you won't be able to study everything with straight lines. So we need something more. So that is where we define something called a polar coordinate system. So everything that is related to circular motion and everything, we prefer to use this system. So how does this system work? Again, listen carefully. So end of the day, it is all about giving an address. So in this system, this is how you give an address. We have a reference line. R and theta. Now see how is the address given. So when you say R comma theta, so just like X comma Y, the meaning of this is draw a circle of radius R with center as origin. And rotate angle theta from the reference line. Example. So if I give you something like 5 comma pi by 3. Now listen to the meaning of this. The meaning of this is from the origin, draw a circle of radius 5. That means your address can be anywhere on this circle, right? That is the meaning of it. When you say radius 5, your address can be, your point can be anywhere on this circle. So from reference line, rotate 60 degrees. You always rotate, clockwise. Rotate theta anti-clockwise. We will see why we use something called right-hand thumb rule. We'll discuss that later. So from here, rotate an angle of pi by 3 or 60 degrees. There. So this point ka address is 5 comma pi by 3. Is that making sense? Didn't I locate a point here? Just like giving X and Y, I can also give you the address of a point by giving you radius and angle. Similarly, if you want the address of this topmost point, can you tell me what will be the address of the topmost point? It is on
5
a circle
comma
of what?
pi by 2.
Yeah, you can type in the chat box, na? Yeah, let others also try. You can always type in the chat box to the co-host. So what will be the location of the topmost point? It will be 5 comma 90 degrees, isn't it? Is that making sense? So just by giving you a radius and an angle, I can tell you where is the location. Is that making sense, everyone? Suppose if I give you like this, let's say 10, 135 degrees. Can you tell me where is the point? Draw a circle of radius 10. So from here, rotate 135 degrees. So it will be somewhere here. And this angle is 135. This is the address. Making sense? So if you complete 360 degrees, you'll come back to the same point again. Is polar coordinates making sense, everyone? So end of the day, the coordinate system is always about finding an address. So either you can give me x and y, or you can give me radius and angle, and I will get the answers. So this point ka address will be 5, 180 degrees. You have to rotate 180 there. All clear with this? No. So in a polar coordinate system, this is how the world will look. Imagine you are living in a world of polar coordinates. If you are a polar creature, and you're not a polar bear, but let's say something like that. Polar coordinates. How will the world look like? The world will look like concentric circles. A coordinate system will look like this, na? Graph jaisa. This world will look like this. In this world, right? You have two directions. Actually, this is how Chandigarh looks like. If you have ever been to Chandigarh, right? The city is a planned city. The entire city, right? They designed it with the ring roads. So we have an inner ring road, middle ring road, and outer ring road like this. So here, any traffic that is there, they keep going on this. So they have names like sectors. So they have residential areas here, we have industrial areas here, we have commercial districts here. So things are like this, kind of, not exact circles, but something like that. They made it. So Chandigarh kind of looks like this. So in this world, how we go? We have two directions in polar coordinates. We can move clockwise or anti-clockwise. So that is one direction. So this is called tangential direction. You can move clockwise or anti-clockwise on a circle. Right? And we can also move radially away and radially inward. I'll tell you how it looks. Remember in X and Y axis, we had two directions. You can move along X axis, along Y axis, right? Here it is move either tangentially or radially. So this is called radial direction. Or you can say, let me use like this, move away or towards center. This is called radial direction. So for example, let's say you want to go from this point to this point. So listen carefully how to go from A to B. So in this world, now you can't go like this, right? You can't go like this. So these are not acceptable. So in this world, what you can do, let's say this is A and take this as B. You can go in a circle like this. So you can travel along the circles. Then you can travel along these roads. You're getting the path? Either you go along the circle or you go towards the center and away from the center. You can even go like this. You can go straight like this and you can go like this completely in a straight line. This is also acceptable. I can even go like this. I can go out. Then I can go like this. Then I can come like this. I can come like this. Like this and like this. This is also acceptable. You always go along the circle or towards this thing. So if you ever been to Hyderabad, right? Even Hyderabad has two ring roads. They have an inner ring road and they have an outer ring road. So what they do, for example, if someone wants to go from this part of the city to this part of the city, The shortest distance is this, isn't it? But if you try to go through this path during the peak hour in the afternoon or even evening, it takes 2 hours. That distance might be like 14 kilometers or 15 kilometers. So you know what most people do? From point A, they go to the outer ring road. And on this outer ring road, the speed limit is 120 kilometers per hour. So people normally go minimum 100 speed there. They have a minimum speed limit. You can't go slower than 80 kilometers per hour. So they hit almost 120 kilometers per hour. They reach the other side and they go here. This thing takes 45 minutes. You travel more, but you save time. So you divert all the traffic into the outer ring road, which is like an 8-lane highway. The problem with Mumbai, we don't have enough space to build a road like this. You can't do this for cities like Mumbai. But in the cities like Hyderabad, or if you take any internal cities, Delhi, you have a lot of space surrounding the city. You can build ring roads like this, and you can let the city develop in the middle. So in this kind of a city, right, the traffic will always keep moving. You'll not get much of a traffic jams. So that is there. So the polar coordinate system, right, is very useful to study circular motion. So just have an idea about it. When it comes in circular motion, again, I'll teach you then. But the thing is, you should have an idea. It is not always X and Y. So polar coordinates are useful. While studying circular motion. Is this clear, everyone? Great. Now, what if someone asks you how to convert from polar to Cartesian? Every time you need not use only one thing. I can use both at the same time. Conversion between Cartesian and polar coordinates. Quite a useful thing. We are going to use this a lot later on also. So if you have a circle, look at the idea here. So I will draw both the axes at the same time. So this is your x-axis. This is your y-axis. In polar coordinates, this point coordinates are r, theta. So what is the meaning of this? Take a circle of radius r and rotate it by angle theta. So we got a right angle triangle. So this coordinate is x and this coordinate is y. Agreed, everyone? Now, from the right angle triangle, what is sine theta? Sine theta is opposite side y by r. There, you got y coordinate is r sine theta. So this is how you can convert polar coordinates to Cartesian or Cartesian to polar coordinates. Cos theta is x by r. So there you got x coordinate is r cos theta. And since it is a circle, I know Pythagoras theorem, x square plus y square is equal to r square. And I can also write tan theta is equal to y by x. You get in the relation, everyone? So if I give you r and theta, I can find x and y. If you give me x and y, I can find r and theta. We can do either way. Have a look at this. Let's see a few problems on this.
Sir, how did the y coordinate become theta?
Y coordinate became theta. Who said that is a y coordinate, God? Polar coordinates, na, r comma theta.
Oh, sorry. I mixed up it. Sorry.
Yeah, this is polar, na? So you're trying to convert this polar r comma theta into x comma y. We're trying to get both. Got it?
Okay.
If I give you Cartesian, you can represent that in polar. If I give you polar, you can represent it in Cartesian.
Okay, sir.
All clear with this? Devanshi, clear? Yashvi,
Yes, sir.
Tanishka, Pratyasha, clear? Advait, Arya, got this? Advait can't see you, right? Do adjust your camera a bit. Make sure your faces are completely visible. Let's see a question on this. So I will give you the polar coordinates. Let's say if I give you r comma theta, then you have to tell me what is x comma y. If I give you x comma y, you have to tell me what is r comma theta. First thing. So let's say this is 5 comma pi by 3. What is x and y? Suppose if this is 3 comma root 3, then what is r comma theta? 10 comma 53. 2 root 2 comma minus 2 root 2. You're getting what I'm asking? So someone gave in polar coordinates r comma theta. If you represent this in x and y, what is the coordinates? If I give you x and y, then what is r comma theta? You're mixing up both. Let's get this. You got an answer, you can type in the chat box with the co-host. Slope. Yeah, we do have concepts like that. We'll not get into so much. We don't have slope kind of thing there. You can type in the chat box here. So you actually have, right, just like, y is equal to mx plus c, equation of a straight line. In polar coordinates, you have equation of lines, you have slope, you have a lot of stuff. That's completely a different mathematical topic. We'll not go that deep. You don't need it also. I just want you to have an idea about r and theta bus. I don't think even you have it in advance also, Max. Mein. We do have few answers. Try. I'll give you a minute, then I'll show you the first two. Everyone should try. It's okay if you get a wrong answer, but try. You have to give me both x and y coordinate. Okay, 6 comma 8. Okay, I thought 6.8. Should I show you the first one? See how to do this thing. Again, don't try to remember any formulas. Forget about the formulas. Try to understand what is the meaning of it. You said 5 comma pi by 3 means what? Draw a circle. This is x-axis. This is y-axis. So this circle ka radius is 5 and this is 60 degrees. That's it. So draw a circle. You'll see this clearly. This is x coordinate and this is y coordinate. So what is x? Cos 60, x by 5. X is equal to 5 cos 60, 5 by 2. Sin 60, y by 5. Y is equal to 5 root 3 by 2. Done. Clear, everyone? What was the next one? 3 comma root 3. How to do this thing then? Now again, draw a circle. 3 comma root 3. I know it will be somewhere here. 3 comma root 3. So this must be the radius. This must be theta. So when you drop a perpendicular, so this is 3 and this is root 3. So what is tan theta? Tan theta is opposite side, root 3 by 3, which is 1 by root 3. So theta is 30 degrees or pi by 6. What is the radius? Radius will be root over Pythagoras theorem. 3 square plus root 3 square. That will be root 12, which is 2 root 3. Therefore, what is r comma theta? So r comma theta is 2 root 3 comma pi by 6. Understood what we did? That is how you do. You put a circle, put the point 3 comma root 3 on that, get the radius, get the angle. Any doubts on this? So this is how you convert polar to Cartesian or Cartesian to polar. You get both of them. Any doubts on this page?
Sir, could you explain the B part again?
See now, the point 3 comma root 3 is on a circle, isn't it?
Yes, sir.
So if it is on a circle, so this is radius r, this is 3, and this is root 3. That's a right angle triangle. If you do Pythagoras, I'll get r.
All right,
And
sir.
tan theta will be opposite side by adjacent side. That will give you theta.
Okay, sir.
Sure. So once I got r theta, that's what I want to find, right?
Sir,
Can you do C and D
theta-
also?
will
R.
Theta was
still
given.
the fourth question have like two answers?
No, there's only one answer. You can't get two answers.
Sir,
Mm-hmm.
yeah,
Go on,
if I consider a circle of radius of just unit length, 1 centimeter or 1 meter, whatever, then can I
Yeah.
directly call the coordinates as cos theta and sin theta?
You can do that. Yes.
Okay, sir.
Let's get C and D. Get this. I'll give you a minute more. Try, everyone. Devanshi, done? Let's try. So 10, 53. How does that look like? So we have a circle. So we took a circle of radius 10. The angle is 53 degrees. Same story. Drop a perpendicular, that is y. Drop this thing, this is x. Then we have cos 53 is x by 10. But what is cos 53? Cos 53 is?
3 by 5.
3 by
5.
Therefore, you get x is equal to 6. Sin 53 is y by 10. This is 4 by 5. Y is equal to 8. Easy? What is the last one? 2 root 2 comma minus 2 root 2. Again, listen to the story. Always draw a circle. Always draw x-axis and y-axis. If you're comparing both, you need to draw. Now you're asking 2 root 2 comma minus 2 root 2. So 2 root 2 will be somewhere here and minus 2 root 2 will be somewhere here. So this is the point. Positive x and negative. This will be the radius. Now be careful. This will be the angle. The angle is always measured from the reference line from the positive x-axis, isn't it? You should measure the angle complete circle like that. And this angle will be how much? If I take, for example, let's say if I take this as alpha, so radius r will be root over 2 root 2 square plus minus 2 root 2 square, Pythagoras theorem. That would be how much? 2 root 2 is 8, 8, 16, 4. And alpha will be,
Minus
tan
40.
alpha will be opposite side, 2 root 2 by 2 root 2, which is 45. So there are two ways you can write this. You can write this thing as 4 comma minus pi by 4. That is also acceptable. Or you can write it as 4 comma, how much is that? 360 minus 45, that is 315 degrees, or 7 pi by 4. Is that making sense? Either you rotate 315 degrees anti-clockwise, or you rotate 45 degrees clockwise, negative direction way. Both are acceptable answers. You can have negative angles also, just like you have a negative x-axis.
Sir, I don't completely understand.
Which part?
The why are we taking theta outside of it and
Because that is a definition, no? The angles are always measured anti-clockwise.
yeah, okay, sorry.
So the thing we always have to rotate in the anti-clockwise direction. So if you want to start from here and reach there, technically speaking, you should go like this, isn't it?
Yes, sir.
So I am suggesting this is also acceptable. If you go in the opposite direction, I can take a negative angle. Clear? Yeah, you can write minus 45. That is also fine. All clear with this? Any doubts on this?
So
Let's have a
does
small
the
5-minute
second
break.
coordinate does the
Mhm.
second coordinate have to be in radian?
Yeah, it has to be in radians. That is generally the SI unit. Yeah, you can give it in degrees, but see, exam anyway, you'll have options, right? You can check out from there. If they're given degrees, give it in degrees. If they're given radians, give it in radians. No? Take a small break. Come back by 9:37. We'll continue in 5 minutes. Go away from the screen. Just look outside for 10, 1 minute or 2
Sir,
minutes and then come back. Yeah.
sir, I had a doubt in the worksheet which you sent.
We will see that
In
end of
the
the class,
seventh,
Arya.
okay.
Any other doubts in the class today? Whatever you have done? Take a break. Come back in 5 minutes. All doubts you will see at the end of the session. But if you have anything that I have taught till now, that you can ask now. Pi is 180 degrees. So we have done that in the last class. Here. So pi is 180. So pi by 3 is 180 by 3. Vanshika, I did share a small sheet in the group, maybe 12 questions, not much. Solution for first question is what? Yep. Now let's see something little higher. Now this part, what I'm doing, right, will be useful for advanced part. Means me generally they won't touch this, the polar coordinates. So what we did is 2D polar coordinates. So just like we have X, Y, Z, we also have a 3D polar coordinates. So how do you do polar coordinates in 3-dimensional? And you might think like, oh, why do we need this exactly? So the interesting thing is, tell me one thing. When you're actually going on the Earth, how are you actually going? Are you going in straight lines? Tell me one thing. If you catch a plane from Mumbai and go to Dubai, and from Dubai you catch a plane and go to Moscow, how are you actually going? Are you going in straight lines?
No, sir.
You're going in curves, isn't it? So tomorrow, let's say if you're designing, drones, and you're designing the path of a drones, let's say you're having a drone swarm or something like that. You have 1,000 drones you're controlling and you want them to go from point A to point B. So do you think you'll give coordinates from A to B in a straight line? You know what will happen if you give the drones coordinates in straight lines? Imagine, now this is the Earth. I'm exaggerating the figure. So if your drones are here, and let's say you tell the drones to travel some 30 kilometers, right? You want them to go to, let's say, point A to point B. Now understand the Earth is actually a curve. If you tell the drones to go 30 kilometers, you know what the drones will do? They'll go in a straight line. So when they reach location B, they won't be at B. They will be above B, or they might even be actually at a shorter distance, isn't it? Because this distance is 30 kilometers. This arc length is 30 kilometers. You told the drones to go in a straight line. They overshot here, so they reached here. Now imagine those drones are carrying bombs. You want to attack enemy, depots or enemy vehicles or something. Isn't that a problem? Chalo, let's not use violence. Let's say you're using drones to deliver your pizza. Instead of delivering it to your house, it delivers on the next floor. You'll not be happy about it. So, especially when you're going long distances, right, and you're traveling, if you see this entire programming that you do on drones, you have to do it in 3D coordinates. For short distances, it is okay. But once you are traveling at distances of, 10, 15, 20, 30 kilometers, the Earth curvature will start mattering. Clear? So you actually lose precision. So 3D coordinates does matter. So how do we actually tackle 3D coordinates?
Sir, is it like latitudes and longitudes?
Yeah, it is like latitudes and longitudes. So actually your latitudes and longitudes are actually 3D coordinates. So what we do here, we go in two different circles. So we have a horizontal circle, we have a vertical circle, longitudes and latitudes. So here in this thing, the address will be r comma theta comma phi. Because for Earth, r is almost constant, we ignore that and we simply give you latitude and longitude. But you can also change r also. So here, this is how the reference goes. This is the center. This is your reference line. So theta rotates in the horizontal circle. This is theta. The angle phi rotates in the vertical circle. This is angle phi. Able to visualize how it is? So you are going in a horizontal circle, you are going in a vertical circle. It's like when you travel from Mumbai to Dubai, you're traveling in a horizontal circle. When you're traveling from Dubai to Moscow, you're going in a vertical circle. The longitudes and the latitudes. So here, theta is a angle in a horizontal plane. Phi is an angle in a vertical plane. So listen carefully. So how do you convert this into Cartesian coordinates, x, y, z? So if you want to get this in terms of x, y, z, then how do we get the coordinates? But everyone is getting the idea here what you're doing, r, theta, phi. Just like x, y, z, we have r, theta, and phi. So you need two angles and one radius to get anything in 3-dimension. So just to give an idea, the picture, so when you look at a globe, you're actually looking at 3D coordinates. So this is the center. This is the reference. So when you're going on this circle, this is your theta. When you go on this circle, so let's say if I take the point like this, so this is theta. And when you go in this circle, this is phi. This point ka address is r comma theta comma phi. There. You're getting how we located the address? So from the origin, draw a sphere of radius r. Now it's a three-dimensional thing.
So here
Now
R
this
is the distance.
r is the radius of the sphere. Think of like this, no? See, let's say when you say radius is 10. So from this point, draw a sphere, three-dimensional, like a globe. So the point can be anywhere on this globe, isn't it? Then if you say theta is 60 degrees, means what? On this horizontal circle, listen everyone, if you got this, I think you'll understand most of it. If you rotate 60 degrees here, you will reach this point. Now understand here. All these points on the circle are at 60 degrees, isn't it? When you rotate 60 degrees, so you are on this vertical circle, isn't it? So you can be anywhere on this green circle. So when I say phi is equal to 45 degrees, so on the green circle, rotate 45 degrees, you reach the location. Are you getting how we got the coordinates? On a sphere of radius 10 meters, you travel 60 degrees horizontally, and then you rotate 45 degrees vertically, and you reach the location r comma theta comma phi. Olivia, is that clear?
Sir,
Confused? Yeah.
sir, then why are latitudes parallel and longitudes like from one point?
That is fine. That is Earth ka thing, na? That is just we gave for our convenience. Olivia, is this clear?
Name this again.
I'll tell you. Confused? It's little difficult 3D visualization, but let me show you one. I have to draw the picture better. Listen carefully here. Everyone sees this thing. Let's say I want to find an address 10 comma pi by 3 comma pi by 4. So how do I locate this address? So first take a circle of radius 10. Okay. This is your equator. Let's keep it simple. Let's take this as equator. This is your center. This is your reference line. So from the center, you rotate an angle 60 degrees in the horizontal direction. Is that clear? This is your theta. So this is draw a sphere of radius 10. What is pi by 3? Rotate 60 degrees in the horizontal direction. So far clear, everyone? So you rotate 60 degrees in the horizontal direction. What is pi by 4? Rotate in vertical direction, means you have to go towards the pole. Meaning from here, I will draw a circle like this, basically a meridian. So in geography, that's what we call a meridian. And this angle is 45 degrees. This is the location of the point P. Is the diagram making sense, everyone? So first you sweep, if you're looking at the screen, right? First you sweep 60 degrees, then you go up. So there are two circles you're talking about. One horizontal circle, it is going left and right. One is going up and down. So you rotate 60, then you rotate 45 up. Are you able to visualize? Now let's try to do this thing. Okay, now you're sitting, right? Think of like this. You're sitting, you are the origin. Okay, stretch your right hand to the right side. Stretch your right hand to the right side completely. So now that length of your hand is the radius, or stretch your left hand if there is no place. You can stretch any one hand, it doesn't matter. Stretch any one hand wherever there's a space. So the length of your hand is the radius of the circle. Agreed? Now rotate your hand 60 degrees in one direction towards you. 60 degrees towards you. Then rotate 45 degrees in the upward direction. Now your tip of the finger is the location, isn't it? Can you see the two angles now? You rotate horizontally 60, then you rotate vertically 45. The tip of the finger is the location of the point P. Is that making sense, everyone? So tell me on this thing. Again, with your hand, if I say theta is 30 degrees and phi is 90 degrees, where are you? If theta is 30 degrees and phi is 90 degrees, where are you? You're exactly on the top, na? North Pole. Did that make sense? If suppose theta is 90 degrees and phi is 60 degrees, where are you? If theta is 90 degrees and phi is 60 degrees, where are you? You're in front of you, isn't it? The point is in front of your face at an angle of 60 degrees up. Are you able to make sense? Suppose if I say theta 120 and phi 60, where are you? Theta 120 and phi 60.
Slightly towards.
So from the right hand side, from the right hand side, you rotate your hand 90 and you have to go further, isn't it? The hand will go, you'll cross your head and you'll go here, and then you go 60, right? You're looking on the left up, isn't it? Now are the angles making sense? Suppose if I want to find a point behind your head, can you tell me what are the coordinates? You are the origin, you want the coordinates exactly behind your head. What are the coordinates?
Theta should
Your right hand is there. Your right hand is here. This is 0. You want a point behind your head.
Both 90.
Both 90?
uh,
Both 90, where will you be there? Both 90 will be North Pole.
theta 90 and phi maybe like 30 degrees.
Theta
180,
minus
na?
90.
There are multiple ways you can reach here. See, if you say theta 90 and phi 180, hand will go completely back, isn't it? You're getting it? Theta 90 and phi 180. Or you could have done much simpler, theta 270 and phi 0. Isn't it? I can rotate 270 degrees and I'll not go phi is 0. I'm behind my head. Is that making sense, everyone? So tomorrow, if you design a robot, right, and imagine the robot head is here, and you want to tell the robot to see somewhere here, what will you tell the robot? You can't tell the robot, na, see to the right side, see right corner, see left corner. Do you think the robot will understand the instructions? So if I am the robot there, and if you tell me, right, robot, look at an angle of 45, 45. This is what you'll write the limits. So what will the robot do? So if let's say this is my position, right, I'll rotate 45, 45. There I'm looking here. Making sense? So imagine you're designing a robotic arm. How will you tell your robotic arm to move? If you see your shoulder, right, actually goes in a circle, isn't it? Your neck goes in a circle. Most of your body motion, if you see, right, there are circular motions inside. You just can't use XYZ coordinates to solve most of the stuff. Is this making sense, everyone? So to fly drones, right, or you need to move a robot ka head, right? Even if you look at your wrist also, see, if this is my wrist, if I say theta 90, this is one angle, this is one angle, isn't it? Can you see I have two rotations here? So even your wrist has two-dimensional rotation. It can rotate horizontally, it can rotate up and down, it can rotate left and right. There are two axes of rotations. So it matters a lot, especially when you're designing stuff and all. You can't design everything in terms of X and Y. Clear with this stuff? No. So I got a point here. Let's see a little geometry now. This is how they'll ask in advance. So normally mains and bits, you know what they do? They will give you a concept which is there in the portion. So portion mein whatever is there, they'll ask you. They might ask you something new question, but they'll ask in the portion. Advance mein what they do, not everything, maybe around 10% of the paper, right? They'll explain you something completely new which is not in the portion. And then they'll ask you to solve the question. It's a pretty common trend. So this is what happens. Suddenly out of nowhere, they'll hit you with something and they'll expect you to solve. So let's say this is X, this is Y, and this is Z. So I'm putting polar coordinates with the Cartesian coordinates. From here, we have a random point here, somewhere r, comma, theta, comma, phi. Can you find X, Y, Z coordinates for this? So P is a point on the sphere. So this is how you teach the robot how to see in X, Y, Z, even though your neck is rotating in r, theta, phi. Find the coordinates of the point. Find X, Y, Z of point P. Don't worry if you're not able to solve the question, but if you're not understanding, please ask. Get these things cleared.
I don't
What I'm trying to
understand
teach you, right? Which part?
I mean, how did this come in X, Y, and Z?
So what are X, Y, and Z exactly? They're just coordinates, right? Axis. If I give you r, theta, couldn't you find X and Y?
Yeah.
Now I give you r, theta, phi, find X, Y, and Z. You're not able to visualize a 3D sphere. See, if you're looking at my screen, this is the sphere. This is X, this is Y, this is Z. So you have X, Y, Z coordinates, right? And sphere tha beech mein. See, X, Y, Z is simply your imagination, isn't it? So how will you get r, theta, phi into X, Y, Z?
Sir, is X r cos theta, Y r sin theta, and Z r tan phi?
Nay, that is not the thing. Again, the purpose of teaching this problem is not that you'll get into this, coordinates and all. I want you to learn how to visualize in 3D. I am trying to teach you that. It's quite important. Physics mein, you need to know two things. It is not concepts. Concepts are hey. You need to learn how to visualize in space. If I give you a structure, you should be able to visualize in space and visualize in time. So what do you mean by visualize in space? If I give you something in 3D, you should be able to visualize how does it look, in do I have anything that I taught you? Look at, for example, look at this problem. Ant wala problem kiya last time yaad hai? So here you are visualizing what would happen if you make this cone into a flat surface. This is visualizing in space. Right? The second thing is visualizing in time. So if I give you a situation and if I ask you after some time, something like this, I won't say exactly, but something like this. After some time, the block has come here. So how much is the distance moved? After some time, how does it look? So you need to think things, in terms of time and space. So this will help you to visualize how 3D structures will look like. Think for a minute, I'll show you. Now, this is a complex part. Getting it, this will be tough. Even your seniors have difficulty even in 12th standard. So don't worry too much about it. Just try to absorb as much as you can. And after explaining, you can ask me if you're still confused. I'll help you out again. The main purpose of this is to make you think in 3D structure. How will you see a sphere? So imagine you are in the center of a sphere and you're in the middle of a big globe. How do we get X, Y, Z coordinates for this? R cos theta, R sin theta. Nahi, Arya, that is not the answer. No, Shreyans, it won't be. R cos theta, R sin theta, no. Should I help you? Listen carefully. Yeah? We'll go step by step. So
Sir,
just look at the coordinates. Check it out. So listen, everyone. So let's go one at a time. So we will just first figure out the x and y axis ka thing. This is your x-axis. This is your y-axis. You're getting how it is two-dimensional plate. It's into the plane. Okay. Now, the first thing is r comma theta comma phi. So the C is somewhere on this line here. This is your y-axis. So the point P is somewhere here. Now see, tell me one thing. If I drop a perpendicular from here, this angle is theta. Agreed with this? So we are looking at that point P there. So the angles will go like this. So you rotate angle theta from the reference line. So this is angle theta. Let's call this point C. Let's call this point A. Now from point P, if you drop a perpendicular, do you think it will come and fall on point C? It will be slightly inside, isn't it? So it will fall somewhere here. Let's call it point D. This is the perpendicular. And this is radius R and this is angle phi. Can you see the right angle triangle, how it looks? Let me
Sir,
show
we
you one
take
more
radius.
picture of the same. Let me show you the same thing in another way. This is X. This is Y. So this point P is somewhere in the air here. You dropped a perpendicular onto the floor. This was point B. This was point A. So you know how are the coordinates? Look at the coordinates here. This is your X coordinate. This is your Y coordinate. This is your Z coordinate. Now you're able to visualize the 3D thing. X, Y, and Z. In this is angle theta. Now if you drop a line here, this is angle phi.
So still kind of confused.
Not able to see the two triangles perpendicular to each other?
I can, but then I keep losing the figure. It's kind of hard.
There you go. Listen again. I'll draw the whole thing again. See. So first of all, let's see how did we reach C, okay, again. So this is your x-axis. So this is point A. So on this circle, rotate an angle theta. This is fine. That is angle theta. Then from here, vertically go up angle phi. Is this clear, everyone?
Yes, sir.
You're going up. When you did this, you reached a point P here. Now from point P, if you drop a perpendicular, you will fall somewhere here, D. Is that making sense, everyone? Again, ask yourself, see, put your right hand to the right side, stretch it. Now rotate by small angle theta. थोड़ा आगे rotate करो theta. Now go up by angle phi. Now the tip of the finger is the point P, isn't it? Now from that finger, if you drop a line straight down, that is point D, na? The tip of the finger is point P. From there, if you drop a line down, that is point D, isn't it? Are you able to visualize that? And this point is B. So this point is C. Aditi, so far clear with this? Now, what I'm
Yes.
suggesting here is, if I draw a line here, this is x-axis, this line is y-axis, and this line is your z-axis. अभी दिख रहा है?
हाँ, sir.
Is this making sense, everyone? Are you able to visualize the three coordinates in 3 dimensions? Any doubts on this? Please ask me. Anuj, Arya, Ishman, Devanshi, Ananya, Sudiksha, Vanshika, Yashvi, clear? Trishi, got this? Utsa, Siddesh. So now once we got this, I think we are done then, kind of. Check it out again. So what we can do now, I'll just make this bigger. What is this length of this line here? What is the length of this line?
R.
R, na? Then in this triangle, let's call this O. So in triangle OPD, this is point P. What is sine phi? Sine phi is opposite
PD
side
by OP.
by OP, na? PD is what? Z coordinate, isn't it? So Z is R sine phi. Z coordinate aa gaya. Agreed, everyone? And in this triangle, what is OD? Cos phi is OD by OP, right? So from here we get OD is nothing but R cos phi. Any doubts on that? Now, once you got OD, now if you take triangle OD, let's call this point here ODB. In ODB, what is cos theta? Cos theta is x by OD. So what is x? OD cos theta. But what is OD? OD is R cos phi. Therefore, x coordinate will be R cos theta cos phi. Similarly, sin theta will be y by OD. So you'll get y coordinate, it will be R cos theta sin phi. All I did is simply 2 right angle triangles. The main headache is visualizing how to do it in 3-dimensional. Are you able to visualize this now? How, Vidya?
Y will be equal to sine theta into R cos phi, right?
Y will be. I'm sorry. You're right. R sin theta cos phi.
So
Mhm.
my name is Ovia.
Oh, yeah. I'm sorry. Vidya. Clear now, Vidya? Got this? All got the coordinates?
Sir, I just had one doubt. Radius,
Hmm.
radius we take of the reference line. So, like,
Arey God, on a sphere, every point is at a distance r from center.
huh?
On a sphere, every point is at a distance r from center.
Okay, so you took above
OP is
one.
radius, isn't it? OP is r.
Okay, fine.
Is this clear, everyone? So if I have to show you my artistic skills, this is how it would look. So this point is B. So basically we got one triangle like this, and we got one triangle like this. So this is one triangle on the floor. This is one triangle on the perpendicular. So basically these are 90 degrees here. If you're able to visualize, how is that? This is OBD. I'm very bad at drawing these things. How do I even draw this? So something like this. Are you able to see? It is like this. If you're looking at my screen, they're like these two triangles, perpendicular. But clear now? So that is your final answer. So if you have a coordinate, I'll just write on the final answer here. You can note it down. Quite a useful result, saves you time. So the coordinates will be x, y, z will be r. What did we get? R is r cos theta cos phi. R cos theta cos phi. R sin theta cos phi. R sin phi. There. So this is your x coordinate, this is your y coordinate, and this is your z coordinate. You should definitely try to derive this on your own again. Maybe tomorrow when the class gets over, right? Try this on your own. This really helps you to visualize in 3D what we did. Tell me one thing, once you understood the figure, was it really that difficult to solve? All I did is simply two right angle triangles, sin theta, cos theta. I just did that only. Is this clear, everyone? So can you tell me the coordinates of this thing? If I give you something like 10, 53, 37, what are the coordinates of this x, y, z? Just do it roughly and tell me. So if I give you polar coordinates 10, 53, 37, what are the coordinates of this point, x, y, z? Any answers? Hmm. 24 by 6, 24 by 5, 6. We have one answer. Not sure whether it is right. Anyone else got this?
Sir, it's by 5, not by 6.
Okay. Aditi, you got x coordinate. Get me all the three coordinates, no, Aditi? Over again, you can simplify that further, na? 5 to cancel hoga. Get this, there's nothing. Just formula substitution. Theta phi डालना था उसमें. Okay, Vanchika, that looks 32 by 5 आया क्या? Second one, I think that looks right. Samya. Oh, yeah, you're also right. You just need to cancel that 5. I think you would have got it. But is the last one 30 by 5? Yeah. Okay. Okay. Samya, last one 6 by 5, or is it only 6?
6 by 5.
6 by 5. Why are these people getting 6 then?
No, only 6, sorry. Only
Okay.
6.
Yeah, and most of you got it. Simple, na? Matlab, this is the z coordinate, this is the x coordinate, this is the y coordinate. Substitute here. Sin 53 is 4 by 5, sin 37 is 3 by 5, cos 53 is 3 by 5, and cos 37 is 4 by 5. All clear with this? Now, how they'll ask this question in the exam? So if this was an advanced paragraph, I will explain you this story like this. This is the 3D coordinates, and then they'll ask the question. Let's see a question. I know this can be a little tiring, but it is important. You should learn how to visualize this thing. Because later on, as we go ahead, right, you'll even have something called 3D integration. You should know how to take elements and stuff. But this will help you, like in that way, you should be able to see stuff in 3D. And for example, if I ask you one more question like this thing, say, can you tell me if you stand on the sun and if you look at the earth, if you look at the moon, what will be the path of the moon? If you stand on the sun and if you look at the moon, how do you think the moon is going? Got the question, right? If you stand on the sun and look at the moon, how do you think it is going? It goes in a jalebi motion, isn't it? You ever seen a jalebi?
Yes, sir.
It looks something like this, isn't it? So if I ask you to study this, what will you do? You will go mad. You're like, what? But we can study this. How? Don't look at the moon. From the sun, look at the earth. The earth will be going on some circle, isn't it? Approximately a circle. And about earth, the moon will be going in another circle. So the motion of the moon with respect to sun is actually a combination of two circles, isn't it? So whenever you want to look at the moon, you don't look at the moon directly. You look at the earth and then from earth, look at the moon. Is that making sense? Same thing.
Sir, will it be like a uniform or irregular?
It's irregular. I said just not jalebi. Jalebi is not uniform. Never seen a jalebi when they make it.
Like, will it return to the same point after one revolution?
Not necessary. Na? Sun itself is not at rest. Sun is not fixed. Sun itself will move. The whole path is messed up. And Earth is not in a circle in the first place. So that is also an ellipse. So it won't come back to the same point. It won't be a closed figure if that's what you're asking. Can you tell me how will this look like? If you're going on your cycle with a red color marker, mark any one point on the cycle ka wheel. Now, if the wheel starts rolling, can you tell me how will this point look like? On your cycle tire, you take some red paint and put it on this thing. And if you roll this cycle ka wheel, how will the path look like?
Like a wave.
That's very vague, right? Wave only, but yeah. How? So this is a daily thing which you
Like a
see this kind of
spiral?
stuff. Spiral nahi hai. So when after some time when the wheel comes here, the point will reach the topmost point, right? Then again when the wheel comes down, point again comes down here. So if you actually try to draw, it looks like this. It's not a circle. This thing is called a cycloid. And this is how it would look. We're going to do this problem later on in kinematics. There. Can you see this path? That is how it looks. When a wheel goes, that point will be following a path like this. This is not a circle. This is not a semicircle. It's not a sine wave. This is a name for this called cycloid. And it is a pretty interesting property. You know what is the property there? If you want to go from A to B, right, you want to leave a ball from A to B. So design a path where it will take the least amount of time. So you can design multiple paths, isn't it? You can draw a straight line. You can make a platform like this, or you can make a circle like this, or you can even make a track like this, vertically and down like this. You're getting, there are different ways you can make a path from A to B, isn't it? And what we find is, if from A to B, if you connect it with a cycloid, that is this path, that takes the least time. That takes the least time. Out of all the paths between 2 points, the cycloid will always take the least time to go from A to B. That means in your local park, if you design, this kids ka slide, And if you design it like a cycloid, and if you leave the kid here, the kid will come down the fastest. And you might think like, okay, so what is the big deal about this? Just imagine if you're designing something like this in an airport, luggage handling, getting it? And you want to get the luggage from A to B and you put a cycloid here. Every time they throw the whatever, the suitcase or something, it reaches the luggage the fastest. And let's say if it saves 1 second of time every time, in a year or in a month, the airport handles more than, like 1 to 2 crores of luggage pieces. It saves you time. You'll have less people working, you'll have less infrastructure, less cost, saves you money end of the day. So if you're going to design and you're designing stuff, you should know which things will work properly, which things are more efficient. So like that way. Clear with this? So Max gives you the function, but we physics people try to use it. So let's see the question, how they'll frame on this. So you have taken a plane. So on Earth, let's say radius is r. So this point A is your equator. So this is what you're doing. Now you know all the basics to solve these kind of questions. The only headache is keep visualizing, and I know my diagrams are not great. I'm not a great 3D artist. I can't even draw normal things, but still. I think the last time I drawed a horse and people thought it was a dog, but yeah. So we have a radius r here, we have point A here. So an aeroplane, you can even replace this with a drone. An aeroplane flies from A to B along the equator. So you started at airport A and then you started flying like this till B. You're going on that line. Maybe I should draw this horizontal line more bigger. This is better. So from A, you're traveling like this till B. So angle AOB is 60 degrees. So this angle is 60 degrees. So on the equator, you went from A to B in 60 degrees. हाँ रिया बोलो ना. Right? Then
Sir, I'll
when you
ask
think
you
of
my
it,
doubt later.
let's say you went from Mumbai to Dubai. Then it flies from B to C, right, towards North Pole. Getting it? Where the angle BOC is also 60 degrees. Meaning you started flying towards the North Pole like this and you reach C here. This angle is also 60 degrees. You getting? How did you fly? You flew from Mumbai to Dubai horizontally, then Dubai to Moscow. So you went horizontally, then you went up 60 degrees and 60 degrees. I think now the diagram is better to understand. I think now it looks more perpendicular. So the first question is, find the length of the line AC. Basically, find the displacement of the aeroplane. That's what we'll do right now. B, I'll give you this as a homework. So after reaching point C, the plane flew back to point A in a shortest path. If plane flies back from C to A along the curve, along the surface, find the length of arc AC. Is this clear, everyone? what is the length of the line AC? Basically displacement and distance traveled. So something like that they can ask you. So the plane flies from A to B and B to C. What is the length of this line AC?
Sir, in terms of?
You can take R. Radius R is equal to 10 meters. Let's make it big one. Let's take it as 1000 kilometers. Or you can leave the answer in terms of R. That is okay. Leave the answer in terms of R. Let's not take numbers. Let's go. Let's finish off. Last one for the day. I know 3D structures have tired you out. Don't worry. Next chapter we are starting off vectors. That is a little easy and comfortable. But even in that, you'll get 3D structures later on. But not as complex as this. If you got the hang of this, I think you can handle most of it now. How do we start? Help you out. Can you find the coordinates of A and C? Start from there. A is on the equator on the x-axis. Can you find the coordinates of A and coordinates of C? How to find the coordinates of C? Just now I taught you. So if I know coordinates between 2 points, can't you find the distance between 2 points? Don't you know distance formula? Then you're done, right? That's it. Itna hi tha. Find the coordinates of A, find the coordinates of C, then use the distance formula. You got the length of the line. Finding the arc is a headache. That you try as a homework. We'll see in the next class. There, anyone wants this results, you can see there. Z is this, X is this, and Y is this. So here R is R, theta is 60, phi is also 60. aa gaya na coordinates directly. So this point A is on the equator, so this is x-axis. So A ka coordinates will be R, 0, 0. X, Y, Z. You're on the x-axis, right? There is no y coordinate, there is no z coordinate. So R, 0, 0. Similarly, C ka coordinates will be how much? C ka coordinates are R, theta, phi is R, pi by 3, pi by 3. X coordinate of C will be R cos theta, cos phi, which is R cos 60, R by 4. Y coordinate of C will be R cos theta sin phi. That will be R cos 60 is half and sin 60 is root 3 by 2. Root 3 R by 4. Z coordinate of C is R sin phi. Wait, I did something wrong here. R sin theta cos phi. Luckily, since both are 60, answer worked out. This is R root 3 by 2. All got the coordinates? So we have coordinates. A ka coordinates are R, 0, 0. C ka coordinates are R by 4, root 3 R by 4, root 3 R by 2. Any doubts on this? Then what is the distance formula? So if you have A, x1, y1, z1, and if you have B, x2, y2, z2, I think you learned in school 2 dimensions. 3 dimensional formula is similar. The distance formula is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the distance between 2 points. There. So using this formula here, now you can solve here. So AC will be root over r minus r by 4, 3r by 4 whole square, 0 minus root 3 r by 4, so minus root 3 r by 4 whole square, 0 minus root 3 r by 2 whole square. R comes out. This will be root over 9 by 16 plus 3 by 16 plus 3 by 4. This will be root over 12 by 16 plus 3 by 4. That will be 12 by 16 is also 3 by 4. 3 by 4 is 3 by 2. So R into root over 3 by 2. Check.
Sir, is my answer for the B question correct?
We'll see. Is this clear, everyone? So you guys got R root 6 by 2. Same thing, no? Okay, right, you got it right. Right, Samyak, you also got the same thing. Yeah, multiply and divide by root 2, you'll get it. Right, you got the same thing. Is this clear, everyone? Now, see, the question looks easy because you know polar coordinates ka x, y, z. If you didn't know that, and if you saw the question for the first time, how does it look like? It looks like why this plane is flying so weird, horizontal, up and down, but in real life, that's how it flies. All clear with this? There, with that, this is done. So basic max polar coordinates and all, we have more varieties there, but we will see them later on. Right, when we have a pretty good questions on based on this. But again, if you're able to get this, I think you got the hang of it. Now we have a small homework question also. So do try that second part. I want you to find the arc length, this AC ka arc length. Try to figure it out. We'll see the answer in the next class. Okay, so that is the last one for the day. So everyone, make sure whatever we did today, I know it went over the head for a few of you, but I hope you understood the end of the explanation. So please make sure to go to the notes. If you're confused somewhere, there's a recording. If you're still confused, I am there. So ask me in the next class, but get it clear. Don't feel shy. The important thing is this. You didn't understand something and you don't ask, and you'll keep that doubt for 1-2 weeks. The next chapter will have a problem. The next chapter will have a problem. So this will just keep on piling up. So don't do that mistake. You have a problem, get it sorted by next week. Right? There's no need to feel shy, nothing. If you're feeling shy, just stay back till the end of the class, ask your doubt, and then only leave. Let everyone leave, and then you ask your doubt personally if you're feeling shy, but get it cleared. The biggest problem is this only. Again, I'm telling you one more thing. See, whatever I teach you, if you understood 80% in the class, I think you're doing fine. 20-15% will go over the head. After going home, revise the whole thing, try to understand, and then come back to me with whatever you didn't understand. That is how the learning process goes. Maybe in school you understood everything on the first try. Unfortunately, real life doesn't work like that. Right? But tell me one thing, whatever I did I teach anything out of the world here other than right angle triangles? Everything that I did in this last 50 pages or whatever questions I did, I just taught you basics only, right? I didn't teach you any new big concepts. But did you see the type of problems we did? You need to think. You just can't put a result in the formula and get an answer. It doesn't work that way. So my strong suggestion would be this result in a derivation, take a pen and paper, sit with this 10-15 minutes, try to derive this on your own. Angle, you listen to me right now, right? You understood. Try to do this tomorrow. Trust me, you won't get it first 5-6 minutes. You'll struggle. That is how study works. Then try for 10-15 minutes, you will get it. If you still don't get it, then look at the answer. Then you will get it. So please remember that. If you think I attended the class, so I know the subject, I will get the marks. Trust me, you will be for a big disappointment. Whatever I teach you, next day at least open the notes. Each and every question you should try to do on your own on a rough paper. That is how you revise the notes. You don't read the notes like a novel. Clear with that?